Okay, here are our notes on precision versus accuracy, as well as density and derived units. Let's start with identifying from these bullseyes what we think each of these are. So we're going to identify if we think that the targets here, the darts, if they're accurate, if we think the darts are precise, both, or neither. So let's start with this one over here in the corner. I know in darts we want to try to hit the middle, so hopefully we're all in agreement that this is not accurate. But precision means that we're going to hit a target in a spot multiple times. It doesn't necessarily have to be the correct target, it doesn't have to be the correct spot, but we're going to hit that spot multiple times. So I would also say that this is not precise. So after hearing those definitions, hopefully you can maybe identify here that we've hit the target, so I definitely would agree that we're accurate, but because we have 4 of these darts all in the same spot, I would also say that we are precise. So on this one, we're definitely not hitting the target, so we're not accurate, but because these 4 darts are hitting a spot with multiple trials, then I would say that it's precise. This one's kind of a trick question. It's definitely not precise as they're all not hitting the same spot, and it doesn't at first glance look like it's accurate, but we can say that the average of these 4 darts is accurate. So don't ever forget that the average might be accurate if we've got multiple runs going. So go ahead and take a second and make sure that you get that written down and that you label those correctly. That will help you with your density lab, as you'll have to label bullseyes again to see if you can identify if they're accurate or precise. Hopefully you took the time to label those, so now let's talk about what precision is and get a better definition. So precision refers to the closeness of a set of measurements to each other. It requires that multiple trials measuring the same thing be done. So for example here, 2.22, 2.23, and 2.21 show good precision. Notice here, I don't know what my target value was, so I can't say whether or not I was accurate, but I do know that I was precise because here are my values of measurement. Alright, now we're going to move on to the definition for accuracy. Accuracy refers to how close an answer is to the accepted or correct value. So we can say how close the answer is or how close the average of the answers are. It requires that we know the accepted value, and then in order to figure out how accurate we were, we look at percent error, and hopefully percent error is familiar from the milk carton lab, and we'll talk about that equation in just a second again. But you, for the most part, will pretty much use percent error on almost every lab that you do that we use values in, because we're going to try to create a quantitative situation where we're looking at how close to the accepted value we are. A lot of times we'll also use qualitative labs where we're looking at observations. So qualitative, remember, is just looking at observations. So when we do that, we probably won't use a lot of percent error. But when we're using values, we're going to use a quantitative data, and we will look at using percent error to help us see how accurate we were. So let's first start with error. So error is different than percent error. Error is simply the experimental value minus the accepted value. So you will do this equation on our density lab, so please make sure, like, error and percent error are 2 different things. Error tells us how high or low we are, how much higher or lower we are from the accepted value. So we can have a negative value here. If we have a negative value, that means that we're lower than the accepted value. If we have a positive value, that means we're higher than the accepted value. So you will need to calculate error on our density lab, just so you know. So please make sure you're aware of that. And then our percent error is the experimental value minus the accepted value, absolute value divided by the accepted value, times by 100. We obviously want the percent error to be low. We do this absolute value here because we obviously can't have a negative percent. So those are 2 equations that you need to make sure that you know for the density lab. So now let's move on to derived units and density. So chemists make measurements to study the properties of matter. We work in SI units and we use significant figures. We make conversions. So you know SI units already, you know significant figures already, and we've also talked about conversions. So we're going to make conversions between different scientific units. When we do that, sometimes we use or create derived units. So what are derived units? They're mathematical combinations of units. So examples are miles per gallon, meters per second, square centimeters, density, and centimeters cubed. Go ahead and pause and make sure that you get all those examples down. Okay, so hopefully you got those examples down. Let's move on. So what is density? Density is a common physical property. Okay, physical property is really important here Okay, density is a physical property, so we've studied physical and chemical properties in this unit, so density is a physical property, and it relates the mass and the volume of a substance. So density, the equation, is mass divided by volume. So it has to be mass over volume, so that's an important thing to remember. It has to be mass over volume. And we can measure it in grams per milliliter or grams per centimeter cubed. And hopefully you're thinking to yourself, that makes sense because we proved in our milk carton lab that 1 milliliter is equal to 1 centimeter cubed. So let's do a practice problem here with density. So what's the density of a substance that has a mass of 84.7 grams and a volume of 55.4 centimeters cubed? So please go ahead and pause the video and try this practice problem, and then when you click play again, I will show you the answer. Hopefully you pushed pause. So when you set up your problem here, so I'm big on showing work, including units. So even if you get the correct answer but you don't show your work, you're not going to get very many points for the answer. So let's say in this case, this problem was worth 3 points. Showing your work, right, like this, showing your setup with the units would be worth 2 of those 3 points. So once we divide that, hopefully that was your setup, once we divide that we get 1.53 grams per centimeter cubed. This would be another point. A half of that point would be showing the correct units in your answer. So please be diligent with your units and with showing your work. Alright, let's look at another example here of using density as a derived unit and as a conversion factor. So you're going to have a question like this on your practice problems. You're going to have a question like this on your lab. You're guaranteed to have a question like this on your test. So please make sure that you're paying attention. So what's the volume of a substance that has a density of 1.73 grams per centimeter cubed and a mass of 7.75 grams? So here's how I like to look at this. I have a derived unit here, because it's a gram per centimeter cubed, and then I have a value that's a single unit. So what I like to do when I'm doing conversion units is I like to start with the single unit first. So I like to start with that in my upper left-hand corner of my T-chart. So there's my single unit, and I like to start with it in my upper left-hand corner of my T-chart. Hopefully from the conversions practice, you're very familiar with the next step that we're going to have to do is put our unit down in the lower left-hand corner to make sure that our units match. So grams and grams have to match. This should be very, very familiar to you. Then what we're going to look at is ask ourselves, do I have a gram to centimeter cubed conversion? Normally I don't, but in this case I am given the density and it is telling me that 1.73 grams is equal to 1 centimeter cubed. So I do have a gram to centimeter cubed conversion in this case. So once I figure out I can convert between those two units, I'm going to include my values, so I know that 1.73 grams is equal to 1 centimeter cubed. Once I do that, I'm going to make sure that my units cross out. I'm going to check this value right here and make sure that it's in the correct units that my question is asking me for. So my question is asking me for volume, and my units are in volume, and it's dry volume, but it's centimeters cubed, so that's volume. So I know that I'm done with my calculations, and I'm able to calculate. So we're going to multiply across, and then divide, and my correct answer would be 4.48 centimeters cubed. So again, this would be showing your work, all of this with the units, and this would be the correct answer with the units in there. So thank you so much for taking the notes. Please come ready to class, and we're going to be able to get to our density lab and hopefully be able to get you through a lot of the post-analysis questions as well. Alright, thanks.